Today we are going to talk about, continue talking about images. Last time we talked about the two main categories of images, which are vector and bitmap images. And don't confuse bitmap with the Microsoft format of BMP. Alright, those are also called bitmaps. The BMP, and if I'm talking about the BMP format, I'll say BMP. If I'm talking about the generic bitmaps, I'll say the word bitmap. But the BMP format is an example of a bitmap format. But it's not the only kind. Actually, JPEGs and GIFs and PNG files are all bitmap formats. SVG is a format that is used for vector graphics, and the graphics that we create within Flash are vector. And we saw the difference between the two last time when we took an image, and we took an image within Flash, and then we took a JPEG image that we created and made them bigger. Our circle in Flash got bigger and still looked like a circle. The circle, because that's, again, a vector graphic. The circle that we made in Paint, I believe, that was a bitmap image, that was a JPEG, got distorted as it got bigger. It got what was often called pixelated. Yes?
Is it wrong to say a raster image?
Raster is, yeah, raster is another way to refer it. Raster and bitmap are the same.
There it is.
Yeah, that might remove the confusion between the BMP format as well. If you just stick with raster, that's pretty good. It gets pixelated, or it gets jagged. In other words, it would look like a series. Our circle looked like a series of steps going up and down that were rounded. All right. Our focus in this class is going to be on raster images, bitmap images. And we'll talk a bit about the different formats that are involved today. And we'll talk about some assumptions, and we will maybe make some parallels between this and audio, because again, one thing I want to do is sort of reinforce all the concepts down the line, because there is sort of a relationship between the concepts. And again, one of the fundamental ideas of multimedia is the size and quality move together. So as the size gets bigger, the quality gets better. And that's almost impossible to see. Right. Size and quality move together. So a bigger size and a better quality will typically mean better quality. And a smaller size will typically mean less quality. You know, it's almost intuitive, right? If better quality, didn't cost you some extra size, then why would you ever have a low quality image, right? So it kind of makes sense. It kind of goes back to, you get what you pay for, and what we're paying for in this case is in terms of bits and download speed and all that. One thing I do want to point out is that when you're talking about images, it only needs to be as good as it needs to be. All right? And I realize that's kind of a statement that's always true about everything, but I guess what I'm saying is, depending on what you're showing in your image, you might not always want the highest quality image, just like depending on what you're showing or recording in your audio file, you might not need the highest quality. If you're recording music, you probably want higher quality than if you're recording someone's voice. If you are an artist that's showcasing your work, you might want a higher quality photo than if you just have a little picture of someone, like saying that they wrote this article, like some places do, some publications do. They'll have the author of the article and have a little snapshot of them on the side. That really doesn't need to be that great of quality of a photo. What impacts the size of an image? There's three things that impact the size of an image. And again,
resolution.
one second. The assumption will be that when I'm speaking of images, I'm speaking of raster images. Okay, resolution. What do you mean by resolution?
Most high quality images be around 300 dots per inch.
Okay.
The one to show on the screen be around 17 dots per inch.
Okay. And let's back up because there is some confusion concerning dots per inch. All right. Dots per inch is really dependent on the context and the particular media that you're storing it on. There's really a good article here that I was previewing before class that talks about that dots per inch really isn't the relevant way to say it. I think what was probably a better way to say it is that the pixel size of the image. In other words, the dimensions of the image. All right. The number of pixels. Well, yeah, if you want to call it the resolution. Yeah. Now, to be sure, it affects the quality when you go to print it. For example, a 300 dots per inch will give you a better, if you print an 8 by 10 of a 300 dots per inch image, it'll be better quality than if you did it for a 72 dots per inch. All right, so in that respect, it's, yeah, all things considered, when you go to print it, if you're printing something the same size, it'll be a better quality. But again, if I store an image as so many dots per inch, really that, again, won't necessarily be indicative of the quality of it, or it's not necessarily the best way to talk about the quality or the size. I'm going to right now post this link to Angel, and it summarizes the differences probably better than I can in just a few minutes. So I'm going to go and post this right now so I don't forget. But take a minute and that will clarify it. So, the number of pixels in an image is one of the factors in the quality of the image. That's really analogous to the number of samples that we have in an audio file, right? And the more samples per second, given the same number of time, you know, if you're talking about a minute of audio and the sample rate is higher, that's going to give you a higher quality because you're going to have more samples over the same time. Same idea with the size of an image. What's the other factor that goes into the size of an image? Besides the number of pixels.
How many colors?
How many colors you're going to store? What's called the color depth. All right? And what color depth relates to is how many bits you're going to store for each color. All right? And that varies, and the more that you store, the better quality the image is, because your colors can match what's really out there better than it could if you're storing less. And again, that is pretty much analogous to the bit depth on an audio recording. You know, if we talk about 24-bit audio, it's storing 24 bits for every sample. If we're talking about, you know, other, smaller, it's storing less information. In general, the more information is going to translate into higher quality. What is the third component in the equation of the size of a file, size of an image file? Yeah, what's that? What influences the size of the file? So far, we talked about two factors. All right, we talked about how much information we store about each color, how many colors we store, so how much information we store about each pixel, and then how many pixels there are. All right, those are two factors into the size of an image. What is a third factor?
Yeah, how compressed it is.
How compressed it is, exactly. All right. Let's go to the example that we had last time, where we had a very simple, like an 8x8 grid that was in that just had two colors, black and white. I do apologize. I'm a little scatterbrained because I'm trying to do two things at once, and that never works out very well, despite people that swear that they're great at multitasking. All right, so I posted an article about DPI, and take a look at it, and it will explore, what is meant by DPI and the influence of that. All right, so what do I mean by compression? All right, we talked about last time, and I'm just going to do this for simplicity's sake. And if you can bear with me a minute, I'm going to run to the office. Actually, I'm not, because I don't run anywhere. All right, I'm going to walk briskly to the office and grab a good marker so that my drawings can be seen by people in class and on the recording. So I'll be just a second. Now, this is going to be a simplification, because we're only going to deal with two colors, black and white. That'll make our lives easier. And we're only going to deal by an 8x8 grid, which is not that many pixels. All right. We talked about last time how we could come up with a very simple way of storing images in this format simply by storing ones and zeros. One means black, 0 means white, and then we'll store a number for each place on a checkerboard. All right? So, if I had this, all right, if this was my image, very simple images, right? I could store that with 64 numbers this way. I could say there is a 1 in position 1. Then we have a white, a white, a white, a white, a white, a white. That's the first row. All right. Then the next row is a white, 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 and so on till we got to the last row. And the last row would be 1, 2, 3, 4, 5, 6, 7, 8. So that would be, we could store this using 64 numbers. All right, 64 numbers. All right. So what accounts for the size of 64? The fact that there's only 2 possibilities for color. All right, and the fact that we have an 8 by 8 grid. If we made that 10 by 10, then we'd need 10 numbers. Or if we stored more colors, maybe we couldn't store a 1-digit number, maybe we'd have to store a 2-digit number. Like if we stored 16 colors, we'd have to have 0 through 15, all right? Then we'd need some extra digits there to store those, all right? So if we stored, 15, if we stored 16 colors and it was 10 by 10, then it would take us 2 times 100, it would take 200 numbers. So you see, the amount of information we store about each color is one factor, all right? Amount of information we store about each color. With black and white, we can get away with just one number, right? 0 or 1. And how many numbers there are, a grid of 8 by 8 is a factor. Now, this is sort of the brute force method of doing this, where we put a number associated with each place on the checkerboard, each pixel in that image. And that is what a Microsoft BMP file is. A BMP file, if you make a BMP file and look at the size, you get the size, if I'm not mistaken, it's been a while since I did this, but I do recall doing this, you get simply the number of rows times the number of columns. All right? Let me do that. Let me make go into Paint. All right. And I'm going to go and I'm going to make a lovely little image here. And I'm going to go and I'm first going to save it as a bitmap. Let's save it as a 256 color bitmap. So I'll go and I'll save this on the desktop. As a bitmap. Also go and I'll save it as a JPEG. Maybe. Alright. Let's go look at their respective sizes. This one's a bitmap. It is 614 by 460. So, $614 by 460 equals 282,000 bytes. Let's see, is that the size? Yeah, roughly. Little bit off. Alright? But essentially that's that size. There might be some sort of header information in there that throws it off a wee bit. But essentially it's the size that I calculated. Alright? I picked 256, by the way, instead of 16 because 256 is 1 byte. Alright? So I could store in 1 character 256 colors. I could store 16 colors in half a character. So that's why I chose 1, so I could multiply it by the dimensions and get the number of characters. Now let's look at the JPEG. The JPEG is going to be fair amount smaller. All right? Half as small, give or take, but in that neighborhood. All right. And if you look at it, both of these look the same. All right? How is that? Well, because JPEGs compress the data. What do I mean by compressing? Compressing is something like this. Yes, I could store this image in this format with 64 numbers. I could probably do better than that, though, right? Because I could say there is one black, there is 62 whites, and then there's one black, right? So 1, 2, 3, 4, 5, 6, 7. We're able to store the same amount of information in 7 numbers, where this way took us 64 numbers, right? Now, to be sure, this is a vast oversimplification, all right, of this. You know, we're only dealing with 2 colors, we're only dealing with 8 pixels. It's real simple, but this sort of gives you a sense of what happens when they compress it. They store it in a smarter way. And again, the kinds of images that they're doing this sort of compression on aren't images that are this simple. You know, there's a lot of colors in a photograph, and it's very difficult to do that compression for there. So people have spent, you know, a lot of time developing algorithms to go and figure out how to do this. All right? I could even come up with something, let's say we had a checkerboard. That looked like this. I'll only draw a few of the rows in. Now you might say I would have to go back and store that uncompressed. 1, 0, 1, 0, 1, 0, because I don't have any contiguous ones that are matching in color. Well, if I was smart enough, I could do something like I have, let's see, what could I do? I could say I have a pattern of black and white, that pattern repeated 32 times, right? If I had a smart enough algorithm to catch that, I could do that. Now again, all right, keep in mind that real images and real photographs are way more complex than this, and would go crazy if we try to understand that. If you really want, you know, if you're over spring break and you're really bored, I think one of the resources talks about the way in which the JPEG compression works. You know, forget about it. It's very difficult, it's very mathematical, and so on. The point is that by being clever, we can compress this and get the same amount of information, essentially, all right, in a lot smaller space. All right? Now, there's 2 kinds of compressions. There's lossless compression and there's lossy compression. What do you suppose that means? Lossless versus lossy.
You don't lose lossless, you lose.
With lossless, you don't lose any information. The very simplistic example I had here was an example of a lossless compression, because with just these numbers, I could recreate exactly the drawing that I wanted. All right, and it would be exact match of the other one. So what's lossy compression then? What does that mean? I guess it's the opposite. So we do lose. What do we lose when we use lossy compression? What does that translate to in the case of a photograph, guys? Not necessarily the size.
Maybe just some small bits of information, some
Okay.
ones or zeros.
Okay. And how would that manifest itself?
So many colors that are
Yeah.
about the same,
Exactly.
that most are related to this.
Exactly. In other words, you know, if you look, and you know, it's kind of fun to do this. You know, I do a lot of digital manipulation just for the fun of it. But if I went and I took a photograph of this wall right here, you might say to yourself, there is one color there, right? That wall is tan. Guess again, if you went and actually looked at that, there would be a bunch of little shades, because if you notice, there's a very slight texture on this. So there'll be little shadows, and there'll be little variations and all that. There might be little dirt markings somewhere or whatever, all right? So even in something that looks like it's one color, there's actually a bunch of colors. Well, depending on the quality of compression you use and the kind of compression, it might look and say, you know what? I can save some space if I use and I store this cream color and this slightly darker cream color if I store it as the same color. If I store it maybe as the average of those two, all right, I can maybe save some space. I don't have to store as much information then, all right? Now, what's the problem with that? The problem with that is you have lost information, all right? You have gotten rid of some subtle differences in shading, for example, in this case, which means that as you save it, it's not really a duplicate of what you originally had as you go and compress it. It's not really a duplicate of what you had. Now, what happens if you were to repeat this process over and over and over again? If you were to edit the same JPEG over and over and over again, and each time it does compression. It's liable to compress it a little more each time, and you're liable to lose some, even, you know, a more noticeable degree of quality. Now, one thing we'll look at when we go to save this, when we go to save something using Photoshop or the GIMP, it will ask us how big of a, you know, what's the quality that we want, 100%, 50%, somewhere in there. And I guess the lower quality you pick, the more shortcuts it's going to take, and the more approximations of colors it's going to use, and so on. All right? So, we talk about JPEG files, and we talked a little bit about compression, all right? And we said that the BMP format is really completely uncompressed, all right, to the point where we could pretty much calculate how big it's going to be simply by knowing how many colors we're going to store and by knowing how many pixels there are. With a JPEG, we can't really make that prediction. We can maybe predict an upper limit, but we can't really make a prediction. We could probably make some predictions that if I took a picture of this wall compared to, say, a picture of, I don't know, one of those charts back there, that file would probably be a bigger file than that file, because there's more variation in that one. Therefore, compression could probably do a better job with that one than it could with that one. All right? But we couldn't necessarily come up with exact numbers. We could guess based on the number of pixels, an upper limit, but again, we wouldn't necessarily know that without knowing the details of how the JPEG compression works. Now, I guess the point is okay, we have the bitmap where there's no compression at all, and we really don't want to use that, right? So we use this JPEG format that compresses it by some sort of magic and comes up with a compressed version of the image that looks the same. I mean, if we look at what we had, that little bitmap I drew, it looks about the same, all right, in the JPEG versus bitmap version, so didn't seem to cause any harm there. I guess my question is, then, why do we have some of these other formats, like GIF and PNG? What's the difference between a GIF file and a PNG file? Still a bitmap. It still records information about each specific pixel. It still uses some sort of compression to compress it. All right. What's the difference then between a GIF and a JPEG?
Like in the GIF, you can have animation.
Yeah, let's forget about the animated